Alright guys, let's do a velocity versus time graph now. So on a velocity versus time, we need to know a couple of things. First of all, we need to know that for the most part, we're going to be dealing with velocity and time graphs that look like this. Very simple ones where the velocity is going up, alright, or down. The line will most of the time be straight. Okay? Some things you need to remember is that the slope of this line is the acceleration. Alright? Because you should notice that the slope would be the change in velocity over the change in time. And you should be able to see that that's the formula for acceleration. Alright? V final minus V initial, that's delta V, over the time. Okay? So let's make sure we remember that. Alright? Also remember, and I'm going to do this one twice just so we can make sure that we see the different variations. The first thing is if you have a graph that looks like this, okay, then the area under the curve, the area between the line, the curve, the red line in this case, and the 0 point here, the 0, 0 mark, is the distance traveled. So this is the change in position. That's what that highlighted area means. The blue area is the change in position, the area under the curve. So the other thing is, the other way this works is if you have a line that looks like this. Okay? So right now, it's the same type of deal. You still have velocity and you still have time. But remember, if you're trying to find the change in this case, first let's just talk about what's going on. In this one, you have a car that in this section is going forward at some speed. Then here, it undergoes a negative acceleration. So from here to here, it's slowing down. So it starts off, I mean, we can call this a number. Let's call it 5 meters per second, okay? So it starts off at 5 meters per second. It's going to slow down to 0. But then once it reaches 0, it's going to keep accelerating in the opposite direction. So now it's going to speed up. I don't know, let's say it reaches 3 meters per second in the negative direction. So it's going to undergo a negative acceleration, slow down to 0 meters per second forward, and then start going backwards at 3 meters per second. So during this period of time here, the object is moving forwards, okay? And during this period of time here, the object is moving backwards. All right? So what you need to know is that the change in position, in this case, the change in position that's blue, will be a positive displacement. The change in position that is yellow will be a negative displacement. So to find the actual change in x for that graph, you will have to do to add the two together. So it should be delta x blue plus delta x orange. All right, keeping in mind that this one here should be a positive number and this one here should be a negative number. All right, the reason being is because this one again is going backwards because the speed is in the negative direction. All right. Last thing with this one is if you have, let's make sure we all can identify what is going on. If we have a velocity and time graph, and we've got this graph here, then if we want to say what is happening, what we can do is we can identify each point. So let's talk about what's going on at each point. During this first section right here, we should notice that it's a constant acceleration. The velocity is constantly changing. All right? So under section 1, you have a constant positive acceleration. Okay? The second section here is a flat line. which means that the velocity is not changing over time, but it does have a constant velocity. Okay, and since the velocity is positive, if it's up here it's positive, if it's down here it's negative. Since the velocity is positive, it's still moving forward. So it's a constant velocity, it's still moving forward. Okay, so in section 1 it's moving forward, in section 2 it's moving forward. Okay, what about this third section here? We're going to stop this third section right here. What's happening in the third section? Well, in that third section, the velocity is still positive, which means that it's still moving forward. Okay, as long as the velocity is positive, it's moving forward, but you should note that it is moving, the velocity is now going back down towards zero. So this means it is undergoing a negative acceleration, and it's coming back down towards zero. All right, this fourth section, the acceleration changes slightly, but this one is now moving backwards. Why is it moving backwards? Because now the acceleration is in the negative section. And so this graph would now be moving backwards. It's going to have a negative acceleration, and this one is speeding up in the negative direction. Notice how 3, we had a negative acceleration, but it was going from some velocity down to 0, right? So this means this one was slowing down. But here, it starts at 0, and it's going to be increasing its velocity in the negative direction. So backwards. It's going to be increasing its velocity backwards. This section right here, section 5, he's going at constant negative velocity, so he should still be going backwards. And then the last section, he is going to have a positive acceleration because the slope, you notice, is positive. He will still be going backwards because his velocity is still negative. All right, and he ends up at 0 meters per second. So he ends up coming to a stop. All right, so let's just go through this real quickly, rehash. This first section, he's going forward because the velocity is positive. It's a slope, so we know that there is a constant acceleration. The slope is positive, so we know that acceleration must be positive. This section, second section, he's going forward. We know this because the velocity is positive. Okay, we also know that there is no acceleration because the velocity is not changing with time. Third section, he's still moving forward because his velocity is still positive. He does have a negative acceleration, though, because the slope is negative. All right, and this guy is slowing down because he is moving from a great speed to a lesser speed. Number 4, this guy is going backwards now. How do we know he's going backwards? Because his velocity has dipped into the negative realm. It's still a negative acceleration because, again, the slope is negative. But in this case, he is now speeding up because he starts at 0 meters per second here, and he's going to a greater speed down here. Section 5, he is now at a constant speed in the negative direction. Since it's a negative velocity, it's still moving backwards. And then this last section, again, he has a positive acceleration because the slope is positive, and he's still moving backwards because it's a negative velocity. All right? You may have to play this a couple of times to figure out what I'm saying. If you do, that's fine. That's the reason I put it on YouTube. All right? So let me know if you have any questions, and we will hopefully have this down now.